In this problem, it says 2 different random samples are drawn from 2 different populations, and then we're given the sample information. And we want to compare the results from a hypothesis test of P1 equals P2. So if we're testing the claim that P1 is equal to P2, then that's our null hypothesis, and the alternative is a not equal to statement. And the original statement, or the claim, is the null hypothesis. So I'm going to keep track of that for later when we're writing our conclusion. Now I'm going to find my test statistic. So this is about 2 proportions. I'm going to do a 2-prop z-test. And that's number 6 in the tests menu. And let's see. So we're going to put in our sample information. X1 is the number of successes for group 1, and that's 15. N1 is 30. Number of successes for group 2 is 1,374. And the number of trials was 1,900. And then we want to write our alternative hypothesis. So in this case, that's going to be that P1 is not equal to P2. So that's the one you want to select. And then you can calculate or draw to get your test statistic. And we get a test statistic of z equals negative 2.70, and our p-value is 0.0069. Alrighty. And they didn't ask for the p-value, but that's fine. And now we want to find the critical values. So we are using a 0.05 significance level. So because we have alpha equals 0.05, and this is a 2-tail test, that means we need to split alpha between the 2 tails. So that means we're going to have an area of 0.025 in each tail. So to find what the critical value is, we want to know this and we want to know this. There's 2 of them. So I'm going to use inverse norm. And I'm going to go ahead, because this is a 2-tail test, I'm just going to find the left critical value, which is going to be a negative. That's fine. And when I put this in the calculator, I get negative 1.96. So now I'm going to come back here. I'm going to adjust my limits, right? I want this to be a little bit before 2 and negative 2. So here we go, like that. And so we have negative 1.96, and then this would be a positive 1.96. Not letting me draw my decimal point there. Okay. All right, so there we've got our critical values. And then when I look at where is my test statistic, that's at negative 2.70. So that's going to be way down around here. And it's falling in that critical region, so that means that I'm going to reject the null hypothesis, which was the claim. So when we have that as the claim, we're going to write our statement, and we're going to use the word reject rather than support. So it's not, we don't reject the null hypothesis whenever the null hypothesis is the claim. So I'm rejecting the null hypothesis because the test statistic is in the critical region. But when I write my statement, I want to use that word reject. And there is sufficient evidence to reject the claim. That they didn't really say what it was about, that P1 is equal to P2. And that's how you do that problem.